Welcome to lesson 4.11. Today we are looking at the pH and pOH scale, explaining what these things mean, and we'll be doing some calculations with pH, pOH, H3O plus, and OH minus concentration. So first of all, quick little math review. If we look at the log function and the antilog function, we see that there are some connections. The base of the log function is the same as the base of antilog or exponential function, if we want to call it that. If we try to solve for the log of 1000, we will get an answer of 3, which is the same. If we put in the 3, raise our 10 to the power of 3 in our antilog function, we get 1000. So what we can see from this is that these are inverse functions. If we put 1000 into the log function, we get 3. If we raise 10 to the power of 3, we get 1000. So we'll get to that later. The formulas we will use are a little bit different than what we see here. But let's go on to the pH scale. The pH scale we see on page 140 in our textbook, but you can just follow along for now and look at what we have, and we'll have some diagrams up later on. First of all, what it tells us is basically if a solution is either acidic, basic, or neutral, the pH scale is calculated using H3O plus concentration, and we'll get to that soon enough. Importantly, it is an easier way to communicate H3O plus concentration. For example, I could say to you, water has a pH of 7, and from that you should take away that, well, water is neutral. If I told you this, the concentration of the hydronium ion in water is 1.0 times 10 to the power of negative 7. This is basically saying the same thing, but a lot more difficult to understand. Okay, so simply communicating with saying something that has a pH of 7 is a lot easier for us to understand. So let's just quickly look at a pH scale diagrams. This is something you may have seen in Science 10 or Chemistry 11, where we have a pH scale of 0 all the way up to 14. We see acidic has values from 7, between 0 and 7, and the basic scale is on all the way up to 14. Actually, right in the middle, pH 7 is neutral, and we see water. Pure water has a pH of 7. Some acidic substances we see are things like lemon juice, vinegar, tomatoes, and basic stuff that we see is baking soda, soap, and ammonia. This scale more is resembling the one that we have in our textbook, and what we want to do is just relate to some of those things we saw on the previous page to this scale. What we said is soap had a pH of 10, and that means it is basic. But what it also means is if we were to describe soap, pH, it has a pH of 10, but it also has a pOH of 4. We also could determine the H3O plus concentration, or see on this scale that H3O plus concentration is 10 to the power of negative 10, OH minus concentration is 10 to the power of negative 4. If we look at the tomato, we saw that it was pH of 4. And again, if we focus on what it relates to is the tomato has a pH of 4, but it also has a pOH of 10. The H3O plus concentration of the tomato is also seen as 1.0 times 10 to the power of negative 4, or OH minus concentration is 1.0 times 10 to the power of negative 10. Before we go away from the screen, so let's go back. Before we go away from the screen, what you should notice, if you add up any pH and pOH value, we will see that it adds up to 14. So 4 plus 10 is 14. 5 plus 9 is 14. And that's something that's important when we start doing calculations later on. So first of all, let's look at the pH formula. The pH formula is negative log H3O plus. And all we have to do is, if we are given H3O plus concentration, we plug that into our formula. So here's an example. We're asked, what is the pH of 0.0035 molar HCl? First thing we do is write down the formula, and then we substitute in our value. Because we're dealing with a strong acid, HCl dissociates 100% So the concentration of 0.0035 is in fact our concentration of H plus or our concentration of H3O plus. We plug this into our calculator and we get 2.455931956. Our final answer, and we're going to have a couple of marks on sig figs on our next test and our next assignment, is 2.46. We have a new rule here that we have to explain. In pH, only digits after the decimal are considered significant. So 2.46. After the decimal, we have a 4 and a 6. Only two decimals, only those two are significant. If we look up above, where the information we began with, 0.0035, the zeros in the front are not considered significant, only the 3 and the 5 are. So if we add 2.46, 2 sig figs. If we had a pH of 12.46, again, only the 4 and the 6 are significant. Another one that might confuse you, if we have 12.06, again, 2 sig figs. The 0 and the 6 are significant. So, what is the pOH of the last example? Well, remember we said pH plus pOH is equal to 14. We simply use this formula to determine that pOH is equal to 11.54. I wouldn't expect you to do this much work, but still, at least this bottom part to determine what pOH is equal to. Next example. We are asked, what is the H3O plus concentration of a solution with a pH of 11.50? Here's a new formula we begin with. We have the H3O plus concentration, and that is equal to 10 raised to the power of negative pH. So we simply write 10 raised to the power of negative 11.50 because that's what we are told up top. We plug this into our calculator and we get an answer of 3.162277766 times 10 to the power of negative 12. Our final answer will be 3.2 times 10 to the power of negative 12. Recall that if we look at the pH value we were given, only the 5 and 0 are significant. 2 sig figs. So that means our answer should have 2 sig figs. You could also be asked what is the OH minus of the last example, and there's two possible ways to do it. We're going to do both ways. First of all, we're halfway on one of the methods. First of all, recall that the pH we were told was 11.50, and we've already calculated H3O plus concentration. So now, step 2 is determining OH minus, and what we do is we use KW, which we've been using since 4.7, lesson 4.7. If we know H3O plus concentration, we know KW, we just plug these values into our calculator, show a little bit of work on our calculation, and we get a value of 3.2 times 10 to the power of negative 3. And that is our OH minus concentration. Or we do it this way. We begin with the fact that pH plus pOH is equal to 14. So we say pOH is equal to 14 minus 11.50, which was our pH. So we get pOH is equal to 2.50. We then determine OH minus concentration by using the antilog function. 10 raised to the negative pOH, which is 10 raised to the negative 2.50. It's what we just calculated in our last step. We plug that in, we get the same answer. And the reason I want to show these two ways is because if we look at the second one, the type of numbers that we have to plug into our calculator are a lot simpler, and if they are a lot simpler, there's less chance of making a mistake in using your calculator. If we look at working with KW, we're dealing with negative exponents, we're dealing with scientific notation. Just having to press extra numbers increases your chance of making a mistake. And I've seen that happen in the past. So what I'm saying to you right now is if you can avoid using KW, go a different route. So in summary, and this is kind of a learning check, you should be able to calculate all these things, H3O plus, OH minus, pOH, or pOH. If you're given H3O plus, what you use is Kw to determine OH minus. If we're given OH minus, we can calculate pOH by using this formula, negative log concentration of OH minus. If we have pOH, well, this one's pretty simple, 14 equals pH plus pOH. If we have pOH, we can determine H3O plus concentration using this formula. H3O plus equals 10 raised to the power of negative pH. We should also be able to work in the opposite direction. If we are given H3O plus concentration, we calculate pH by using this formula, negative log H3O plus concentration. If we have pH, again, we use the same formula, 14 equals pH plus pOH. If we want to calculate OH minus concentration from pOH, we use the anti-log function. 10 raised to the negative pOH will give us OH minus concentration, and if we want to determine H3O plus concentration from OH minus, we use that with Kw. And that is it. What you should be we'll be working on tomorrow in class is continuing on the acid-base calculations assignment, reading and highlighting, skimming through the notes parts, answering the questions, and then continuing on the Hebden questions, numbers 47 to 57. See you tomorrow.